So, when we talk about the six trig functions, we've talked about some fundamental identities already. Tangent is the same thing as sine over cosine. Cotangent is the same thing as cosine over sine. Secant is the same thing as 1 over cosine. Cosecant is the same thing as 1 over sine. And cotangent is the same thing as 1 over tangent. And all that really comes from this idea that sine is equal to y over r, cosine is equal to x over r, and tangent is equal to y over x. So we could play around with that stuff and we can derive those five. And we kind of talked about that in another video. So let's talk about it a few more. When we're talking about the unit circle, we're talking about the equation x squared plus y squared is equal to 1. And if we think about the trig functions in terms of the unit circle, the sine of theta is equal to y over r, but if r is 1, then sine is really just the y coordinate. Cosine of theta is equal to x over r, but if the radius is 1, then cosine is equal to just the x coordinate. That's kind of the premise we've been operating on for the last section or two. So let's take it a step further. What if we were to make a substitution for x and y into the unit circle equation? Then we're going to have cosine squared of x plus sine squared of, sorry, let me use the same. Let me write it this way and explain the notation. So I'm substituting in for x, cosine of theta. I'm going to substitute in for y, sine of theta, and that's going to be equal to 1. So notice I put that in parentheses. Let's talk a little bit more about notation here because this is going to be a big deal from here on out. I want to spend a few minutes on this. So I could write that this way. What that means is I'm taking the cosine of theta, whatever it is, and I'm squaring that quantity. A shorter way to write that is to put the squared between the cosine and the sine. Same thing here. So those mean the same thing. This is a notation you're going to see more often than seeing it written like this. But that's what that means. So we've got this, and we know we can add things in any order, right? So we could rewrite this as sine theta plus cosine of theta is equal to 1. So that's where this identity comes from. My high school trig teacher always called that guy the 5-star general because that's where everything else is going to come from. Okay, that's your big one. So what if we were to take everything in that and divide by sine squared? So we're going to have sine squared divided by sine squared plus cosine squared divided by sine squared equals 1 over sine squared. Well, sine squared over sine squared is 1. Cosine divided by sine. Cosine divided by sine is cotangent. So cosine squared divided by sine squared has to be cotangent squared. And 1 divided by sine is cosecant, so 1 over sine squared. That's the same thing as 1 over the sine quantity squared, right? We could write it the same way. So this is cosecant squared, which is, I can write this way, cosecant squared theta. That's where this guy comes from. Everything goes back to that 5-star general. And then let's do the same thing. Sine squared theta plus cosine squared theta is equal to 1. Now let's divide by cosine squared. So I have sine squared over cosine squared plus cosine squared over cosine squared equals 1 over cosine squared. Sine over cosine is tangent, so that's tangent squared. Cosine divided by cosine is going to be 1. 1 over cosine squared theta is going to be secant squared theta, because that's the same thing as this, and this guy is secant. So just doing some fancy algebra there, and you can see that's where that guy comes from. So we have derived all of those different fundamental identities there. So which ones should you memorize? These you should memorize if you don't have them already. This one you should memorize. These come from this, so you can either memorize them or you can say, hey, I got to divide by sine squared to get one of them, and I got to divide by cosine squared to get the other one. So whatever you need to do to remember that. All right. So I'm going to pause the video, clean my board up, and then come back and we'll do some more. So another thing we need to know, and this is something you may want to write on your unit circle. And that's where each of the trig functions is positive. I wonder if I can write on my unit circle. Let's see if it will let me do that. So here's my unit circle. So we're thinking about this being on the xy plane, right? So here's my xy plane, quadrants 1, 2, 3, 4. In this first quadrant, everything is positive. So I'm going to write all. All 6 trig functions are going to be positive in that first quadrant. And that's because of the definitions, right? The x values are positive, the y values are positive, so sine and cosine's positive, which means tangent's positive. So if we think about over here, what's positive? This is going to be your sine function. Sine's going to be positive here. That also means that cosecant has to be positive. Okay, so why is that positive? Well, sine is the y-coordinate, right? And the y-coordinates are positive in this first quadrant. Okay, cosecant is 1 over sine. Since the y's are positive, then 1 divided by a positive number would also give us a positive number. So here, this is where tangent's going to be positive and cotangent. Everything else is going to be negative down here. So cosine's going to be negative here, sine's going to be negative here. Okay, the reason tangent's positive, tangent is y divided by x, and for every y divided by x in this quadrant, I'm going to have a negative divided by a negative, which is going to give me a positive. And then in the last quadrant, cosine's going to be positive, which means secant's going to be positive. Okay, cosine is your x. X is your positive here. So you can see why cosine's going to be positive. Secant is 1 divided by cosine, so you can see why that's going to be a positive. So an easy way to remember this, I think about it this way. ASTC. Okay, a long time ago, Appalachian State University was Appalachian State Teachers College. That's how I remembered it. You can come up with any acronym you need to remember what's positive where, or you can just memorize it. Some people say all students take calculus. Whatever you need to memorize it, find a way to memorize that. That way you know what's positive in which quadrants. And we're going to use that idea to answer some of these questions. Let's look at a few of these. 27. We want to know where sine is going to be positive. That's what it means to be greater than 0. And cosine is going to be negative. So if we think about ASTC, sine is going to be positive, cosine is going to be negative. That's going to happen in quadrant 2. Okay? Can't happen in 1 because in 1, every single one of them is going to be positive. So it doesn't meet that restriction. So you got to think about, where does this thing live? Let's look at 32. Cosine is going to be negative, right? Because less than 0 is negative. And tangent's going to be positive. So we're going to start by thinking about, where's tangent positive? Tangent's positive here, and the cosine would be negative here, and that guy's in quadrant 3. Let's do another one. We'll do 33. So secant is going to be negative. Secant, if the secant's negative, then that means cosine is going to be negative 2. And the sine is going to be positive. So then cosine negative, sine positive. That's going to happen here in quadrant 2. All right, let's do some of these. We want to find the exact value of each of the trig functions. So we're going to start by drawing pictures. Let's look at number 36. In number 36, they tell us the sine is positive and the cosine is negative. That tells us where this lives. It lives over here. Remember, sine is y divided by r. Cosine is x divided by r. So sine, my y is 4, right? Because that's my y. My x is 5. My radius is 5. And then my x has to be a negative 3 because the radius is a positive 5. So there's my picture. Here's the theta value they're talking about. They're talking about this thing called a reference angle. So let's find the other trig functions. We need to find tangent. We need to find cosecant, secant, and cotangent. Okay. I'm going to start with the easy ones. Cosecant. Cosecant is the same thing as 1 over sine. So if I were to flip that, I'm going to get 5 over 4. Secant is the same thing as 1 over cosine. So that's going to be negative 5 over 3. So now let's find tangent. Tangent is y divided by x, which is going to be 4 over negative 3, or negative 4/3. Cotangent is x divided by y, which would be negative 3 over 4. Okay, let's do one more. Let's look at number 57. I'm going to pause the video, erase some stuff in the... So in 57, they're telling us the sine's going to be positive, but tangent's negative. That tells us where this lives. It has to be over here. It's the only way the sine can be positive, but the tangent negative. Okay, so if you think about what's going on, this is a negative x and a positive y. And remember, tangent's defined to be y over x, right? So we're going to think about this as a positive 1 and a negative 3. We've got to figure out the radius here. And that's going to come from that Pythagorean theorem. It's going to be x squared plus y squared is equal to r squared. So 9 plus 1 square root of 10 is my radius. So I've got tangent. I need to find cosine and sine. I'll start with those two. Cosine, remember, is x divided by r. So it's going to be negative 3 over square root of 10. Sine is y divided by r, which is going to be 1 over square root of 10. Sorry about that. And then we need to find cotangent. Cotangent is 1 over tangent, so it's just going to be negative 3 over 1, which is negative 3. Secant is 1 over cosine, which is going to be negative square root of 10 over 3. And cosecant is going to be square root of 10 over 1, which is square root of 10. Now, don't forget to rationalize. I did forget here, so I can multiply by square root of 10 over square root of 10. Okay, the homework systems are really picky about that in this class. So there's our final answers.